Welcome to section 3.4, where we introduce the product and quotient rules for taking derivatives. So first, let's suppose we have a product of two functions, f of x times g of x, and we would like to take the derivative of this product. Alright, so our rule for this is going to be first take the derivative of f of x by itself, okay, and multiply that by g of x, and then we're going to add that to our derivative of g of x by itself multiplied by f of x. So it's the derivative of one times the other plus the other derivative times the first, right? In function notation, we have f prime of x times g of x plus g prime of x times f of x. And notice we are dealing with addition, alright, so this is also the same thing as g prime of x times f of x plus f prime of x times g of x, alright, so it doesn't matter what order we do this, right, because we are dealing with addition. Alright, so now we're going to look at the quotient rule, which is if we have a fraction, f of x divided by g of x, and we want to take this derivative. Alright, this is going to give us a nice big fraction. So, in our numerator, we're going to first have the derivative of f of x times g of x. Alright, so it starts off similar to our product rule, however we are going to subtract instead of add. We are subtracting the derivative of g of x times f of x. And I said it was going to give us a really big fraction, so there we go. In our denominator, we just have g of x squared. Alright, and so since we are dealing with subtraction here, we cannot switch the order. Cannot switch the order. Whoa. So it's very important we make a note of which is the top function and which is the bottom function that we are dealing with. Alright, again we can write this in function notation. So we have f prime of x times g of x minus g prime of x times f of x over g of x squared. Alright, and if we rewrite it one more time, I'm just going to switch the order of multiplication. Okay, that is commutative, right? So f prime of x times g of x is the same thing as g of x times f prime of x, right? I just can't switch this subtraction around. And I promise I have a reason for rewriting it like this. Okay. So if we look at it this way, we have the bottom times the derivative of the top minus the top times the derivative of the bottom, right? All over the bottom squared. And if we think of the top, so of f of x, if we think of it as the high function, okay, on top, and g of x, if we think of it as the low function, then we get some sort of riddle thing that sounds like a yodel, okay? So we could get this, this low d high minus high d low. So now we're going to actually implement these two rules. Alright, so first we have f of x is equal to x squared times e to the 2x. So this is a product of functions, so we're going to need a product rule. Alright, we're also going to need a power rule and an exponential rule, right? because we have that e in there. So we want f prime of x, okay, and we have two functions. We have x squared and we have e to the 2x. Those are our two functions. So using our product rule, we need the derivative of the first function, which is x squared, times the second function, which is e to the 2x, plus the other way around. We need our derivative of our second function times our first function, right? So this is how we apply the product rule. So now we just go ahead and calculate the derivatives like we've been doing. So the derivative of x squared, that's where we're using the power rule. So we bring the power down and we get 2x times this e to the 2x over here. All right. And then we need the derivative of e to the 2x. So this is our exponential rule of e to the kx. So we pull the exponent coefficient down, but then we leave everything else the same. And then we have this x squared over here. And then to finish up, we just like to drop those brackets. So we have 2x e to the 2x plus 2x squared e to the 2x. And that's our final derivative calculation. Alright, so that's our first application of the product rule. Now let's go ahead and look at an application of the quotient rule. So we're going to need the quotient rule, and it just looks like we're going to need a few power rules in here. So we want p prime, okay, and we need the derivative using the quotient rule. So this is our top function, and this is our bottom function. So we just need to be careful about the order of derivation here. So we need our derivative, in this case it's with respect to q, first of our top function, so of 5q to the third, times our bottom function, so times this q squared plus 1, alright, minus the derivative of our bottom function, whoa, it's a crazy q squared plus 1, times our top function, 5q cubed. But we're not done, it's a fraction, right? So we need all of this over the bottom function squared. So q squared plus 1, all of which needs to be squared. Okay? So let's go ahead and look at these little pieces of derivatives. So we need the derivative of 5q cubed. I'm going to keep saying to the third. Alright, so that 5 is independent, right? So it comes out. We have q to the third. The 3 comes down, so we'll get 5 times 3, which is 15q exponent minus 1, which is 2, times our q squared plus 1. Then we need the derivative of this q squared plus 1. So derivative of 1 is 0, derivative of q squared is 2q times 5q to the third over our q squared plus 1 squared. Alright, and technically we're done taking derivatives here, but we do like to drop these brackets and parentheses and just clean it up a little bit. So I'm going to go ahead and multiply through over here. So we have 15q squared times q squared. That gives us 15q to the fourth plus our 15q times, or squared times 1, minus 2 times 5 is 10q times q to the third is q to the fourth over our q squared plus 1 squared. And then I notice we have q to the fourth here and here, so we can go ahead and combine like terms. And so we get 15 minus 10, that gives us 5q to the fourth plus 15q squared over q squared plus 1 quantity squared. And there we have now finished our first application of the quotient rule. Alright, so there's a lot that goes on, especially in the quotient rule, right? So it's good to write out every single step. Really make sure you're not losing any coefficients or losing, especially that negative, right? Okay. Let's look at example C. We have g of x is equal to 3x squared plus 5x, that whole quantity, times e to the x. Alright, so there's a few different ways we can handle this one. I'm going to do one way and then I'll just mention the second way. Okay? But either way, we're definitely going to need a product rule. And we're definitely going to need some power rules. Power rule. And an exponential rule, right? So if we want g prime of x, we're going to leave it in its current state, so we need the derivative of the first function. We're going to use this as our first function, and then our e to the x is our second function. Okay? So we need the derivative of that first function, 3x squared plus 5x, times our second function, that's an x, there we go, plus, product rule uses addition, so plus the derivative of that second function, e to the x, times the first function, 3x squared plus 5x. Alright, and I'm just going to make a quick note that I'm using these parentheses here because multiplication has to apply to everything that's in here. Alright, if I didn't have these parentheses, this multiplication would only apply between these two and not to that 5x. Alright? So that's why the parentheses are necessary over here, but not over here, because there's only one term being multiplied over here. Okay? So now we just need to go through and take these derivatives. So 3x squared gives us 6x, and 5x gives us 5 times e to the x, plus, I'm doing a few of these steps in my head, so if you ever get lost in between these steps, please send me an email and I'll feel free to, or I'll definitely work them out for you. Alright, we have the derivative of e to the x, which is itself, right, just e to the x, times our 3x squared plus 5x. And then we're going to go ahead and clean this up a little bit. So distribute this e to the x over here. So we have 6x e to the x plus 5 e to the x, plus distribute this e to the x over here. We have 3x squared e to the x plus 5x e to the x. And then we have these like terms here. We can add them together and we'll end up with 3x squared e to the x plus 11x e to the x plus 5e to the x as our final answer for our derivative. Okay, so I did mention at the beginning that there was another way that we could go about this. Alright, I'm just going to move, nope, I want all of that. move that over here. And I'm just going to go ahead and rewrite our function by going ahead and distributing this e to the x inside here. So this is the same thing as 3x squared e to the x plus 5x e to the x. Okay? So if we did this first, we could then take the derivative in this form. However, we are going to have to use two different product rules. So we'd have to do a product rule here and a product rule here. All right? If you did this and you worked out both sets of product rules and everything, you would end up with the same answer. All right? So neither one is more correct, but this way is a little bit more work. All right? But both would get you to the same answer. Alright, so let's look at example 2, where we want to use this table to evaluate the following quantities. So we'd like to find h prime of 1, where h of x is equal to f of x times f of x. Alright, so this is f of x squared, but it's a product, which means we need to use the product rule. So, by the product rule, our h prime of 1 is going to be the derivative of the first, evaluated at 1, times the second, evaluated at 1, and then added to the derivative of the second, evaluated at 1, times the first, evaluated at 1. Okay? So let's go ahead and find these values. So we need f prime of 1, and we need f of 1. So looking at our table, f prime of 1 gives us 3. One of these needs to not be a prime. There we go. So f prime of 1 is 3, and f of 1 is 5. Alright, so we have f prime of 1, which is 3, times f of 1, which is 5, plus f prime of 1, which is 3, times f of 1, which is 5. We get 15 plus 15. We end up with 30. Okay? We'll look at another one. So we want h prime of 1, where h of x is given by 3 times g of x. So we're going to make a little note here. Well, I'll ask you a question. Do we need to use the product rule here? Okay. See what you're thinking? We do have a product, right? We have a multiplication happening here, 3 times g of x. However, so do we need the product rule? Three times g of x is a product, all right? I'm not denying that. However, what is it not? It is not a product of two functions of x, or the variable that we're dealing with. In this case, we're dealing with x. Okay? This is a constant multiple. A constant multiple, and we've been dealing with constant multiples for the last few chapters. We know we could just pull those right outside of derivatives, can't we? So we don't need a special rule for this instance. Alright? So we do not need the product rule here. So if we have h prime of 1, this is the derivative of 3 times g of x. So this is going to be 3 times g prime evaluated at 1. No special rules here, right? So we just need to find what g prime of 1 is on our table. So go up to our table, look at g prime, look at 1. G prime of 1 is 0. So we'll come back down. G prime of 1 is 0. So we get 3 times 0, which is 0. And we have one more example for this problem. So h prime of 2, where h of x is the quotient of f of x divided by g of x. Alright, so here we're going to need to use the quotient rule. So we have h prime of 2. So we need our derivative of the top function, f prime, evaluated at 2, times the bottom function, evaluated at 2, minus the derivative of the bottom function, evaluated at 2, times the top function at 2, all over the bottom function at 2 squared. Alright, so we need a few things here. We need f prime of 2. We also need f of 2. We need g prime of 2 and g of 2. Alright, so let's look at f prime of 2 and f of 2. So f prime of 2 is 4, and f of 2 is 3. Alright, so f prime is 4 and f of 2 is 3. Then we need g prime of 2 and g of 2. So we'll look at g prime of 2 is 3, and g of 2 is also 3. Okay, so g prime of 2 is 3 and g of 2 is also 3. So we just need to plug these values in here. So we have f prime of 2, we have 4 times g of 2, which is 3, minus g prime of 2, which is 3, times f of 2, which is also 3, over g of 2, which is 3 squared. So 4 times 3 is 12, minus 3 times 3, which is 9, all over 3 squared, which is 9. So we get 3/9, which is 1/3. Alright, so now on to example 3, where we're going to use the graph below to find the following derivative values. Alright, so again, we're just going to note that our x-axis is only has lines for every 2 values. Okay, so this is 1, 3, 5, and 7 here. So we want h prime of 2, where h of x is equal to f of x times g of x, which is a product, right? So by our product rule, we have h prime of 2 is going to be f prime of 2 times g of 2 plus g prime of 2 times f of 2. Alright, so we want f prime of 2 and f of 2, and we want g prime of 2 and g of 2. So f of 2. So at x is equal to 2, the point on our f function is 4. And at g of 2, we have 6. Okay. F prime of 2 is the slope of our function at 2. So it looks like we go up 1, 2, 3, 4 over 2, right? Because this is 1 and then 2. So 4 over 2, which gives us 2, right? We're increasing, so positive 2. Then g prime of 2, well, we're negative. We are decreasing and we're going over 2 and down 2. So this is going to be negative 1 for our slope. Alright, so if we plug these values in, we get f prime of 2, so 2 times g of 2, which is negative 1. Times g of 2, which is 6, not g prime of 2, plus g prime of 2, so here's the negative 1, times f of 2, which is 4. So 2 times 6 gives us 12. Negative 1 times 4 is minus 4. And so our answer is 8. Alright. And then we have one more. So k prime of 6, where k of x is equal to f of x divided by g of x. So we need to break out our quotient rule here. So k prime of 6, well, this is going to be f prime of 6 times g of 6 minus g prime of 6 times f of 6 all over g of 6 squared. Alright, so we need f prime of 6, we need f of 6, we need g prime of 6, and g of 6. So let's go back up to look at our graph. So at x is equal to 6, we have g of 6 is 2, and we have f of 6 is 8. So g of 6 is 2, f of 6 is 8. And now we need the slopes at those 2 points. So g of x, our slope has not changed. It's still over 2 and down 2. So it's still negative 1. Our slope at f of x, however, is a horizontal line. So this is a slope of 0, right? So f prime of 6 is 0, and g prime of 6 is negative 1. So let's plug these in with a little bit more space. There we go. F prime of 6 is 0 times g of 6, which is 2, minus g prime of 6, which is negative 1, times f of 6, which is 8, all over 2 squared. So 0 times anything is 0. Then we have negative 1 times 8, but we're subtracting that, so it's a positive 8 over 2 squared is 4. And so our final answer is 2. Alright, so now we have example 4, which is our last example for today, talking about the concentration of a drug in milligrams, which is present in the body and can be represented by this function here. Alright, where t is in minutes since the drug is administered. So we're supposed to find and interpret q of 4 and q prime of 4. Alright, well, q of 4 just involves plugging 4 into our given equation, right? So we have q of 4 is going to be 350 times 4 e to the negative 0.015 times 4. So let's see, 350 times 4 gives us 1400 e, and negative 0.015 times 4 gives us negative 0.06. Alright, and a calculator tells me that this is 1,318. Well, this is the concentration in milligrams, right? So this is in milligrams. So if we're supposed to interpret this q of 4 at 4 minutes, since administering a drug, whatever drug we're dealing with here, the concentration in the body is 1,318 milligrams at 4 minutes in. Alright? So then we need to find and interpret q prime of 4. Well, in order to do that, the first step would be to find our derivative, right? So we need q prime, first just say at t. Alright? So we need our product rule. So we're going to need the derivative of our first function, which is 350t, times our second function, which is e to the negative 0.015 times t, plus our derivative of our second function times our first function. Okay? So the derivative of 350t with respect to t is just 350 times our e to the negative 0.015t. Then we have our derivative of this e to the kt, so we bring the k down, and then we leave e to the kt. And of course still by our 350t. Alright, so we have 350 e to the negative 0.015 times t minus our 350 times 0.015 gives us a 5.25 times e to the negative 0.015 t. Alright, so this is our q prime of t, and we're supposed to find q prime of 4. So q prime of 4, well, that's 350 e to the negative 0.015 times 4 minus 5.25. Oh, what am I missing? I'm missing this t when I multiplied through here. Move that over. Add a t in there. Alright, there we go. So 5.25 times 4 e to the negative 0.015 times 4. of this together gives us 309.84, which I'll go ahead and just round up to 310. Alright, so this is our rate of change, right? So first thing we notice, it's positive, so it's increasing. Alright, then the time is in minutes. So after 4 minutes, the concentration is increasing by our 310 milligrams per minute. And that is our interpretation of Q prime of 4. Well, that wraps up section 3.4 and therefore wraps up chapter 3. So please do remember to take that comprehension quiz and start studying for the next exam. And I'll see you in the next lecture.